Okay, so if I'm looking at the probability, so P, which is probability of getting, you said less than 3 or 4, correct? So remember, or we're just doing it the regular way. So we have our numbers 1, 2, 3, 4, 5, and 6. So if I have less than 3, that's 1, 2. So that's 2 that are less than 3, and how many of them are 4? 1. So 2 plus 1 gives me what? 3 out of 6, which simplifies to 1. Say it again. 1/2. So probability of less than 3 or 4 gives me 1/2 or 3/6. I can't remember if I simplified it or not. Now I am going to call some people out. So Annabelle, this right here, 12 tries, which means that you tried every single possible option until you got them all right. This, my friend, is a no-no. On your assessment, on your classwork, I only give you one option. You get it wrong the first time and it's wrong. It doesn't become more right. So you got to work on actually trying to get that done correctly. Or I will be looking for another activity that forces you to do so. So we're looking at some vocabulary. Now, as far as our vocabulary is concerned, it is very important for you to write down the definition of independent and the next word that we are going to look at. So I would write this down in your notebook. Make sure it is somewhere where you will be able to find it. And you will need it again. An independent event. 2 events are independent if the result of the second event is not affected by the result of the first event. And we're going to look closer at that today. If A and B are independent events, the probability of both events occurring is the product of the probabilities of the individual. So I'm going to give you a minute to write that down, and I'm going to give you I'm going to give you kind of like, I'm going to read through the example and explain it a little bit better. They're not prizes. I'm using it for my example. I should use something you might really want, like cookies in my back cabinet. I mean, who says that? Not even I say that.
I have found that kids don't like chocolates and chocolate candy.
That is true.
Skittles and gummies and all that kind of stuff. Then as they get older, they like chocolate. Like McDonald's chocolate, or she just like candy. I don't much like it all.
How rude.
I've heard you. Yeah, you did. You got some candy.
I have a bag of those at home. Angel, make sure that your microphone is muted.
Oh, I love it. I feel like I'm daily. I love that.
Okay. So I'm gonna do my little makeshift example over here. I figured it was better if I could actually show you with something that I can move around. So can everybody see my markers? Can everybody see my markers? You're not even looking at my markers. Why are you shaking your head?
Yeah.
I know everybody at home can't see my markers. I will do the example again on the board. Okay, so I have 6 markers, right? So if I was going to do, like my event over here, independent, right? So independent means that one is independent of the other. So it's the first, I'm gonna write down with a marker I can't even write on the desk with. So if I'm doing like my first probability, the second one is independent, or they're independent of each other if I'm not doing anything the first time that kind of disrupts the second one. And I know that sounds kind of weird as I'm saying it. Okay, so if I have my 6 markers, correct? And I kind of should have probably put a blue marker. Let's pretend this one's blue. Can we pretend this one's blue? Oh, look, I love it.
Yeah.
Okay, so what's the probability that I will pick a blue marker? 1 out of 6. Remember, probability has to be a fraction unless I ask you for a decimal or a percent. So it would be 1 out of 6, right?
Ooh, look at those.
So it's independent. I'm taking my blue marker, right? And I'm replacing it. So I'm putting it right back. How many total markers do I still have now? I still have 6. So what's the probability of getting a blue marker the second time? 1 out of 6. It would still be 1 out of 6. So we're going to look at, I hate this board. We're going to look at dependent. So dependent is different, okay? So the second probability, don't start writing yet, I want to explain it before you write it. The second fraction is dependent on the first one if it gets kind of disrupted, right? So let's say I have, what's the probability of getting a blue marker? We said 1 out of 6, right? If I take a marker, but I do not replace it, do things change? How does it change?
You want to have fun.
I'm only going to have 5 markers now because I'm not putting the marker back. That's making my event dependent now. Because now what's the probability of getting a blue marker? It's 1/5. So those are the 2 different kind of scenarios. So up until now, everything we see says, and it was replaced, and it was replaced. So the bottom number has been the same. So today we're going to be looking at more dependent probability problems where we're not replacing. So I do want you to write down the definition for a dependent event. So 2 events are dependent if the results of the first event affects the outcome of the second or third event. So sometimes we can even have 1, 2, 3, and on. You can write up until this period, so probability is changed. Okay, give you 30 more seconds, and we're moving on. Okay, let's look at example number 1. So yes, you are going to write this example down, and in your notebook, you can write dependent events. And then example.
I like to wait until it's like, come on, next, I'll move on to the next question. 4. I like this. I should actually take out candy.
You had to bring candy.
I should take out candy and be all like, "Rawr."
Was that one that was like too? I told the kids,
To like pretend something was okay and terrible or whatever, but I don't maybe just be at home. It's not as fun. Oh, way too many markers in my bucket.
Are you judging my kisses?
No.
I heard the laughter the minute I started.
Oh, no, I was telling you. You are committed to this one.
I am. I'm trying.
Yes.
Do I have
How
enough?
else are you gonna show? How else are you gonna work it out with the plan? In your brain.
No. We're using our brains and our hands. So if you don't have it drawn, go for it. Go.
Yeah,
I know you don't
start
have it
drawing
drawn.
it. When you can draw it and you're done copying the problem, go ahead and draw it.
I mean, I know what
You can
else
draw
this.
triangles for the
I know what
kisses.
else this looks like, but I mean, like, I'm not focusing on that. It looks
Yeah.
like a poop emoji.
For real? You can do triangles for the kisses, for the chocolate, squares for the caramel, and you can make them round and in.
Yeah, you can make them round. I wasn't gonna commit to making things round, so I figured squiggly circles would be good enough. So I've got caramels, I've got mints, and I've got dark chocolates. I don't see any chocolates and candies on your page. You better get to drawing. We be making sure we understand everything that's going on here. Let's go. Replacing and not replacing is always the hardest part of probability. We are gonna understand this.
You don't have to be perfect.
You then count.
There you go. Okay. Come on, move your hands around perfect. Dots. No, he wanted to be perfect. That would take a long time. And then just draw triangles for the. There you go.
Well, you still need 16.
And two caramels. We're missing the squares for the caramels.
Okay, so my problem says a jar, and I didn't draw the jar. I wasn't all about that. A jar, this is my jar. My screen is my jar. A jar contains 2 caramels, 7 mints, and 16 dark chocolates. What is the probability of choosing a dark chocolate, eating it, then choosing a caramel? We'll be like, and then choosing a caramel. We're missing that word in there. And then choosing a caramel. So we've got 2 caramels, 7 mints, 16 dark chocolates. How many total candies do we have? How many? 25? Are we sure? Is that our final answer? 25. So we've got a total of 25. Oh, he's going to double check. He's like, I don't think I said it right now. So it says, what is the probability of choosing a dark chocolate? So we're going to choose a dark chocolate first. And then choosing a caramel. So with that and, what are we doing? We're multiplying, and then we're choosing something else, or caramel. So, for our dark chocolate, what would our probability for our dark chocolate be? 16 over 25. Okay, we've got all our chocolates here. I've got all my caramels, everything. So I have 16 over a total of 25. But I took that chocolate and I ate it. And I obviously can't put it back. So now, what's the probability of choosing a caramel? 2 over what? 24. Because since I ate that dark chocolate, it is now 1 less. So it is 24. See, I knew we could do it. The drawing makes the difference because now you can see I took one away. It makes all the difference. So you got to multiply across. Those of you sitting there waiting for me to do it is not happening. Let's go. Don't tell me.
600.
Nah, you can't go.
That is your final answer, yes. Simplify.
I'm done. I'm
You
done.
gotta simplify, my friend.
Okay, so once I simplify, what I get
4/75.
4/75. Good. It's gonna take too long to erase. Okay, let's look at the next one. It says, you have a jar of 14 marbles. 7 are red, 2 are yellow, 2 are blue, sorry. 3 are yellow, and 2 of them are white. What is the probability of selecting a marble that is blue, not replacing it, and then selecting a white marble? So let's read it one more time. You have a jar of 14 marbles. 7 are red, 2 are blue, 3 are yellow, 2 are white. What is the probability of selecting a blue marble, not replacing it, and then selecting a white marble? Okay, so my most important question, now that I read this, is how many total marbles do I have? How many? 14. Good. I want to make sure, because sometimes you guys have the tendency to not read the whole sentence and then end up going 14 plus 7 plus 2 plus 3 plus 2 more. Good. So our total marbles are 14. So Miss Perniz has 1, 2, 3, 4, 5, 6, 7 red marbles. Circles are so much easier to draw. 2 blue marbles. She's got 2 white marbles. And she's got 1, 2, 3 yellow marbles. See, I even made them yellow for you. So, if I'm drawing out my probability, first I did, and then I picked another.
You missed, you got it to white?
Yeah, well, they're,
Yeah, I just,
they're black with the white center.
yeah.
We're pretending it's white because I can't really make a white marble. So what's the probability of selecting a blue marble? 2 out of 14. What am I doing? Times. Now, it says I'm not replacing. So what's happening to that blue marble? How many? I'm taking 1 away because I'm only selecting a, I'm selecting a blue marble. So I'm taking 1 blue marble away. I shouldn't have drawn it in the middle because now I can't erase it. So now that blue marble is gone, threw it away, what's the probability of picking a white marble? 2 out of how many? 13. Because since I took away that blue, my number goes down 1 and I only have 13 marbles left. Good. Multiply and simplify. Without calling out the answer to everyone. Yeah, that's you. You know who you are.
What did you do? Put it on the calculator. Where was the calculator? That's cheating. Well, that's, oh, shame. Oh, well then, alright, we're drawing a team. Okay, alright, so what's working the first one? 12, 11, write down, 13, simplify. That's 15. Remember what we did, yeah, I'll remember we got a simple one. And then, it's not there, you have to be lazy. So, 4 times 3 is what? Yes, you do.
I'm going to start printing out all the sheets for you so that you can work each and every one of them out, drawings and all. You're going to love me after that. So after I simplify, what is my answer?
291.
What?
91.
2 over 91. I mean, at least tell me over. Not 291, that's an actual number. 291. It's not hard. Now, my question is, if I were to mix in replacing with not replacing questions, would it then be easy? I don't know about that. I feel like you guys wouldn't actually read it. Okay. So it says there are 27 students in a class. 13 are juniors, 14 are seniors. What's the probability of choosing a student that's a senior for student council and then choosing a different student and it being a junior? I want you to go ahead and underline on your sheet important information, not on your sheet, on your screen, important information. And I want you to go ahead and figure out what your first probability is. Yes. It doesn't tell you the place you know. I like it though. They have to actually know what to count with.
Yeah.
Well, think about it. Do you? I don't know. You gotta figure that out. I'm glad you asked yourself that question though. That's the very first, that's the most important step. Did you ask yourself that or not? I forgot how many people are on a student council. Like 5? 4 or 5 sometimes. Sometimes like 15.
So when you imagine it like you're picking people 13, right? Once you pick the person, you then get back in and pick them again, and so it's 15. So think about it like that. Which you know what student
Yeah.
I almost put
13.
teens, but
Yeah,
I was like,
that
but
is a good comparison.
We started with still 13, Jackie. We started with still 13.
I'm trying to use the
It's
lightest color
27
on there.
students. 13
Oh, I
students
tried
are
to
40
use
seniors.
the lightest color on there. I don't see probability fractions. Let's go. Start with the first fraction. Don't start making yourself confused. Do the first probability fraction like normal. Think about that second number above your total.
So put your boxes and stuff. Figure out what the first one is, the next one is, and
Okay, let's take a look. Cause I'm looking around and I don't know why you guys are so, like, I know why you're confused about some parts, but I don't understand why on other parts. So it says there are 27 students in a class. So 27 students in a class. 13 are juniors. 14 are seniors. What's the probability of picking a senior for student council and then choosing a different student and it being a junior? Okay, so first of all, does anyone know what student council is? Okay, so best comparison to student council, like Miss Maria and Miss Melvin were saying, think of it as a soccer team. So when you're outside and let's say you're going to play a game, you have two captains, right? And these two captains are looking at this group of kids and they're like, okay, I pick you. Now you stand behind me, right? Does that person go back into the crowd? Does not. So am I replacing that person? No, I am not replacing that person. So think of student council as a group like that. You're not replacing because he's already a member of the student council. So I'm looking at my two fractions because remember, you need to pick one member and then you pick another member. Your first member needs to be a senior. How many seniors are there? 14. 14 out of how many total students? 27. So for the most part, the people I saw that did this first one right. I don't know what happened when we got to the second fraction though. So if it says and, what are we doing? We're multiplying. If I'm not replacing, my total is then going to be what? It's going to be 26 because I started with 27, I took a senior, and I'm not giving them back. And so now I have 26. But the top part is what bothered me the most about what I saw on some people's screens. My second person needs to be a junior. How many juniors are there? There are 13. Yes, you're choosing a different student. That doesn't mean this is going to be one. Because there is not one junior. There are 13 juniors. So 14 over 27 times 13 over 26. I feel like when you guys run into a word or words that you don't understand, it suddenly turns the whole problem into something completely different to you. No, we cannot do that. You change that word or phrase to something else and you keep going. You keep pushing through. So if I multiply 14 times 13, what does it give me? Eh? Let's let Shaylin say it. What is it? 182. 676. Thank you, because all of you speaking at the same time, that wasn't working. Okay, so your last question, you're going to do on your own.
It was 7702. Yeah, what he said. Yeah.
Well, thank you. I appreciate it. I'm glad that this one is like this. So go ahead, I'm going to read it. Then you're going to underline and solve. You have a jar of 20 Starburst candies. Yummy, yummy, yummy. 8 are pink. 4 are orange. 6 are yellow. and 2 are purple. What is the probability of selecting a Starburst candy that is orange, not replacing it because I ate it, and then selecting a pink Starburst candy?
I know, because I was like, well, what other colors are in it? There's pink, orange, and yellow, and I think that's it. And I was like, we're throwing in a purple.
Oh, red. Red are my favorite.
Red are
Those are my favorite. Albin, telling me you can't see my screen after I'm on the last question doesn't really help me. It doesn't help you either. Okay, go ahead and underline and solve on your screen. And once you're finished, submit.
You can do only one thing.
I think for Monday, I'm going to put in one combination problem, one replacing combination, one not replacing, the other, mix it all in. I'm gonna see all on the mix.
Because there was error, it just showed error, so.
Alright, Nana, come on. So let's move important. What is the probability of selecting that one? So write it down. What's it? I want the fraction first of selecting Starburst.
And like, orange, and the pink.
We're not gonna replace them. And I'm
Okay, so
selecting.
it's not the
I
pink.
did it.
Because it was almost there.
It's all wrong.
This one is right. This is 4 out of 20. But that second time, and I put that one, either egg roll or red. I didn't, I took it out because I hate it. So now, how I'm gonna start eating that jar. But I took that orange out and I put that.
Not replace.
You took one. I took one. Yeah. You have to be careful, this is probably the other one, 4 out. I just took one. I took-
Go ahead.
Yes, now you can be right. Well, that's nominated.
Okay. Aquí tienes un orange, ¿verdad? Y ahora, yo cogí el orange Starbucks y yo me lo voy a comer, así que no lo voy a poner en eso. ¿Cuántos me quedan? Si yo me comí ese, ya no tengo 20, sino ¿cuántos tengo?
Finish your password first and then.
¿Y total cuántos tengo? Si no lo vuelvo a poner, saco el Starbucks de la bolsa.
No.
Solo
I was wondering if that was
tengo 20, ¿verdad?
Yeah.
Ya dijimos, si saco un naranja, es 4. Ahora, no lo voy a guardar porque me lo voy a comer. Entonces, como me comí un Starbucks naranja,
And
un
then, yeah, you
Starbucks
see
naranja,
the arrow?
¿cuántos
The arrow
Starbucks
that you
me
can
quedan?
simplify. But every time you see the arrow, means you can
Al
and
nuevo
just like
fracción más
simplify
que
again.
¿cuál
No,
va a
you
ser
have
mi
to
nuevo
just
total?
simplify
Si es
and try.
9
Finish.
y arriba
Okay,
se
see,
va
now it doesn't show
porque
the arrow,
dice
so that's.
not replacing it
So every time you see the arrow, you just simplify it.
and selecting a pink Starbucks. ¿Cuántos pink Starbucks tengo yo? Very good.
Wait, is it what?
I knew I was unpopular. Cuando te dicen not replacing it, es que yo no lo voy a volver a poner en la bolsa.
I've got,
Entonces, ya no tengo 20, sino solo tengo
I
19.
have to read it off in a place.
¿Ok? Y de ahí multiplico.
Cuando
Cuando te dice replacing es que lo vuelvo a poner. Pero si dice not replacing es que lo saco de la bolsa o de la caja o de lo que sea y no lo voy a volver a poner de regreso. ¿Ok?
Okay. There's a little bit of information. you don't know, it's kind of hard. Okay, so the whole deck has
How
four
we doing
different
this?
suits. Okay, you know, are you familiar with the deck of cards, the cards at all?
So go ahead and ask. And then submit it.
Money. And so we're- I mean, like the deck of cards, you play your cards at all? Yeah.
She's
So you know
in the
there's four
calculator.
suits, right? So there's four different suits.
Calculator. Now I need to
cards,
do,
Right? So
okay,
everything
now I
is
need to
divided
do-
inside of four suits. There's 13.
then now I need to use the calculator.
So how many cards are in my deck? There's 13 cards.
I'm trying to
Okay.
get you done for the whole
And
week,
then-
John.
Out of everyone in this
But he's pretty much this week.
Mhm. I think he has,
Uh,
everything
is
is
right up on
So how many queens are in my deck? That's right. Now that you have the information.